My name is Samir. I'm a student at MIT. I just finished my third year of grad school, but I also did my undergrad here. And I studied aerospace engineering, which might explain the presentation I'm going to give you today, AI in space exploration. So this is not going to be a particularly technical talk. I just want to expose you to a field that you might not have considered has a lot of AI involved, both right now and with potential for the future, right? So first, let's just talk about what we're actually doing here, right? We are doing space exploration. Why is this relevant? We already went to the moon. Does anyone know what we have in the future as far as space exploration goes? We'll limit it to, US goals for space exploration. Mars. Mars is a big one. We'll talk about Mars. I want to see if anyone gets anything else. We sent something to Venus we just said we're going to send something new to Venus, right? We actually have another program that's pretty big that no one's mentioned yet. And a lot of you might not be familiar with it. Interstellar travel. That is far off. Definitely hope we have AI by the time we hit interstellar travel. All right. Charles says the moon, and there we go. Someone said Artemis. We'll talk about that, right? So everyone said Mars. This is great. I don't know if y'all are familiar with this, but we have so many types of spacecraft going to Mars, around Mars, on Mars, right? So you can see, let me get my laser pointer on. We have stuff that you might have heard about before, the Hubble Space Telescope, we have the International Space Station, but we also have new rockets we're building, the Space Launch System. We have commercial cargo, commercial crew, SpaceX. We have orbiters around Mars, and we have rovers, right? And landers. And so, isn't a rover from the US and a rover from China there? China just landed a rover for the first time on Mars. We are no longer alone. The US has several rovers and landers on Mars. We're going to see a video of one of them today. But something that I wanted to get on was that we're going back to the moon. This is kind of a big deal, right? The Apollo program was in the 1960s, and we landed humans on the moon for the first time. And now we have a new mission saying we're going to the moon, right? And this is going to be sooner than we go to Mars. And I actually want to point this out that even in this 8-second promotional, video, humanity's return to the moon, we have a picture of Mars right in the background. We're using moon as a staging location for our eventual goal to get to Mars. Now, why am I talking about this? Because we are trying out all new technologies to figure out how to safely and efficiently get us to Mars and beyond, right? Interstellar travel. And so a lot of these technologies are going to be tried out on Earth, on the way to the moon, and eventually on the way to Mars. So let's actually talk about some of those things. We use engineering and AI to solve problems. What are the problems with going to Mars? Some of them might be obvious. Cost. Yep, I hope we can use AI to reduce the cost. I don't know quite how we'll do that immediately. Time is a big one. Temperature, fuel capacity. These are great. Keep going. Okay. Do you see any challenges that could be addressed well with AI? Or actually, someone, Soham, because you're in my group, you said time. What do you mean by time?
Like how long it takes to get to Mars. Like it takes many years.
Yeah, it takes many years to get to Mars. Well, no, actually it doesn't. It takes several months to get to Mars. We can get there sooner. The reason that the rovers take a long time to get to Mars is because they want to be as fuel efficient and as cost efficient as possible. If we send humans to Mars, we're going to take a more direct route, which takes closer to like 3 or 6 months. But either way, it takes a long time, right? We got to the moon in 3 days. Another part of time, which you might not have thought about unless you've seen The Martian, is that it's just far away. When we talk about time, I don't think about the time it takes to get there. I think about the time it takes to talk to someone on Mars. If there's a human on the ground and someone on the space station, you can have a Zoom call, right? Like distance-wise, the space station is closer to me when it's overhead than someone in India is right on the other side of the world. Like that's just true. When we talk about the people on Mars, it will take 7 minutes for a message I send to an astronaut on Mars to get there. For them to hear it, they'll send a reply, and it'll take another 7 minutes for that reply to get back to us on Earth. And what that means is anyone on Mars is basically on their own, right? If something goes wrong, they have to wait 14 minutes. No, phone calls and live phone calls are not possible, right? And this is just one of those challenges. There are a lot of them, right? We have unknown obstacles in a very unforgiving environment, right? We talk about we need to figure out how to solve this problem in a simulation or in a video game. Consequences are fairly low. We need to figure out how to get across this obstacle on a Martian planet where we can't contact any other humans to help us. Might be a big deal, right? Radiation is something. How the heck can we talk to someone on Mars? How do you send radio waves that far? You can't do that on Earth. Well, the Earth is in the way of sending radio waves directly, which is why we bounce them off satellites. The nice thing is most of space is empty. And yes, we don't do radio waves. We convert them to different types of waves on the EM spectrum and send them across. But you're still limited by the speed of light, which means at a minimum, it takes 7 minutes to get to Mars. Good conversation happening in the chat. Other challenges I want to point out, radiation, right? We are very, very happy to live on Earth because we have something shielding us from radiation. We need to figure out how to design computer systems that are resistant to radiation, not just from a hardware perspective, surround the whole thing in lead, but also from a software perspective. How do you design programs that aren't going to be affected by random bits getting flipped on the way to Mars? Gravity, lack thereof. We're talking about human issues now, limited bandwidth I just talked about, and just it's far away, okay? So these are some of the things that we deal with when we talk about designing a mission to go somewhere else in space. And so when I'm going to talk about these challenges and solutions that we have in AI, they might seem familiar to you, but just keep in mind that the consequences are potentially higher and there are new challenges that might not exist when we do them on Earth. And we have that light system in place. Why don't we do that on Earth? Atmosphere makes it very difficult. The huge benefit of space, mostly empty. All right. Let's talk about a couple things. I'm going to talk about a couple different things. The first thing I'm going to talk about is robots, right? So we know about robots. Robots are very cool. We have rovers, right? So here are some technologies that AI is being used in on our most recent rovers, right? There are more obstacles in space. There are obstacles in space. Space is really, 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 really big. There are asteroids, and even if there are, like, just so we're on this topic, all those times you see movies of people like flying through the asteroid belt and like, Star Wars, Han Solo navigating around the asteroids. You actually fly through the asteroid belt and you can make it entirely across, and the chance of you seeing a single asteroid is like negligible. Space is really big. Okay, let's talk about technologies. Here are 3 of them I want to point out. NASA built a self-driving car for its next Mars mission. Everyone's so impressed with Tesla doing self-driving cars, for good reason. NASA's been working on self-driving technology for a while so they can have self-driving cars on the moon, right? The last rover, Curiosity, actually had that technology, and it was upgraded for the newest rover, Perseverance, that just landed less than a year ago. I think it was less than a year ago, just about a year ago, right? And so think about the challenges you have there, where you are not looking at lanes on the ground that are nicely defined for you on a road. You're just on literally another planet, right? Mars Ingenuity helicopter. We have a helicopter on the new rover that's supposed to fly around on Mars. It has a different atmosphere. It has a different gravitational pull. And we can test all we want on Earth, but it's very hard to replicate those conditions on the ground. And so we need to use AI to figure out how we can take initial data from this flight testing and adapt itself, right, to flying on Mars. And, spoiler alert, it's doing that. It had a maiden flight and it's alive and it's working. So we're still figuring out how to make it work, but it's working. Mars new rover will use X-rays to hunt fossils. This blew my mind, right? There's a spectroscopy instrument on the Perseverance rover that uses AI to figure out how and where to point a laser to break up rocks, collect it, and then uses machine learning to analyze the sediment, right? We want to eventually bring artifacts back from these planets, like we have moon rocks from the moon landings. But before we do that, if we can do as much analysis on the ground, we can save a lot of space and weight and cost and time. And so they're using machine learning to just do that analysis on the ground instead of sending a whole bunch of data back to JPL to be analyzed, right? So these are just a couple different things. I want to talk about one thing that is very similar to stuff y'all have been doing this week or last week, right? Let's talk about computer vision. Does anyone want to guess what these pictures are? Anyone want to guess what the background is? someone says the surface of Mars, where water used to be. Close. Mars craters. Okay, it is the moon. It's not Mars. Good job, Angel, or Angel. I don't know how you pronounce your name. This is pictures of the moon, and this is using computer vision in a way that you might not have realized or thought about before, right? The picture here on the left, this is taking a picture of the moon and detecting safe landing spots, right? We talk about driving around and flying. We have GPS on Earth. GPS is a result of satellites, a giant constellation of satellites surrounding the Earth that lets us pinpoint where we are at all times. That does not exist to the same extent in space, especially not on planets, right? So how do we navigate around when we're landing? When we go with humans, we just trust Neil Armstrong to be an awesome pilot and land correctly, right? And he had to do a very harrowing maneuver just to not land in the middle of a crater, right? Here, we're using AI to detect, hey, these are spots that look good that don't have craters. And then this middle image here is a high-res photo of the moon that we have from telescopes and satellites, and says, okay, we've picked out these 5 spots. And the photo on the right is a simulation of a moon landing and says, all right, I have a camera pointing down on my lander. Can I figure out where those spots that I identified before were good to actually land? Because we talk a lot about theory and practice, right? In theory, we can figure this out, but does it actually work in practice? So you got to test all this stuff out. And this might seem, cool. It's still a simulation. I just want to point out the fact that we did this. We did this a year ago for the first time. I'm about to play a video for you from the Mars landing, and I want you to listen to what she says in the very beginning. All right?
At an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Framing.
Yeah, y'all are way off topic in the chat. Totally fine. But I hope y'all were listening to that part right there. It said we have produced a valid solution for our terrain relative navigation. We had a camera pointed down at Mars to figure out, hey, these are potentially good places to land. Let's minimize the chance that we land in a crater. This, let me remind you, it takes 14 minutes for a signal to get from Earth to Mars and back, okay? This whole landing sequence actually took 7 minutes. So basically, by the time it receives the first message on Earth that, hey, we're starting our landing sequence, it's either on the ground or it's like a pile of rubble. And they have no idea, and they just have to wait to see what happens, right? This whole thing is automated with AI, and it figures out exactly where it's gonna land and how to do it safely. Also, if you haven't seen this video, you need to watch it. I think it's absolutely mind-blowing. I'm letting it play so you can watch. The whole technology is crazy, where they drop a rover from a rocket-propelled crane onto the planet, onto the surface of Mars, right? And this whole thing is automated. This whole thing is filled with AI to make sure it's making the right decisions with the most amount of information available with no human intervention whatsoever, all right? So if you think that this AI talk is something that's far off in the future, it's not. We did this. This was last year, all right? Here's something else we should talk about. Humans. Someone mentioned you're an astronaut in space. Okay, it's not like it will take you long to drift your own spaceship, so same thing. Okay, let's talk about humans in space. We have had AI assistants in sci-fi movies for a long time. Can anyone tell me what these 3 assistants are? Anyone know the name of these? I see R2D2. What's up? C3PO, R2D2. We see HAL. The middle one's a little harder. Anyone know what the HAL is? Or what the middle one is? Sorry. TARS, yeah, TARS from Interstellar, right? So this is from 2001: A Space Odyssey, HAL 9000. This is from Interstellar, TARS, and then we have, of course, famous Star Wars, C3PO and R2D2, right? So sci-fi has been telling us that we're going to be going through space and we're going to be relying on the use of AI to guide us, to make good decisions and to assist us in challenging tasks, right? TARS literally picks up a human and saves them from a planet. I don't think that's a spoiler. So here's another video I want to show you. Oh, hold on. Let's turn the sound off.
Pretty good.
All right.
Pretty good at listening. Pitch down 40 degrees.
Wilco, pitch down by 40.
Simon, rotate right 90 degrees.
Okay, turning right by 90 degrees.
All right. I'm not going to glorify this too much. It's basically just a Siri or an Alexa that has access to information and the human can talk to it and get information from it. But I want to point out that there's a whole extra dimension. I am pretty sure if you take your Echo Dot and hold it up in space, hold it up in the air and drop it, it's just going to fall. All right. This AI has to literally figure out how to rotate and move in space in microgravity, right? And so it just adds a whole nother dimension that we don't even think about because we literally don't deal with it on the ground, right? And so that was a video of this actual AI assistant being tested on the International Space Station, right? And so these are things that we're doing right now to help us because we plan on using them in the future for even more complex missions, right? Wow, we're so off topic in the chat, y'all. I really hope that we're not going to rebel against humanity. Okay.
Pretty good at listening.
So keep going. Here's my final slide for you, right? I just want to show you a whole bunch of different technologies that also we're working on right now to assist humans. I don't know, you know what y'all should all do if you get the time? Go watch videos of humans immediately after they get picked up after returning to Earth. And they try to walk and they really can't because it's really funny. It's really funny, but they can't walk. After spending 3, 6, 9, 12 months in microgravity, they cannot walk. It's one of those things that you don't think about. We say, oh yeah, we watched The Martian, they land on Mars, and then they walk out and say, oh look, here I am. Nah, they're gonna like fall over. It takes people 3 days to like acclimate to the gravity on Earth after returning to Earth, after spending their entire life on Earth, but spending 3 months in space, right? And so we need technologies to help us deal with these challenges. This is an exoskeleton on the left, right? To help us with our mobility. We have robo gloves here, another type of exoskeleton suit. We have these different robots. One of them is called R2. I don't remember the name of the other one. And the goal here is that we might want them on our spaceships. We might want them on on extraterrestrial planets, right? To assist us just like TARS does, picking things up, moving them around, assisting us when we can't, right? Maybe we don't want to risk our lives going into an unknown environment. And so this is another use of AI. This robot in the middle here, that's also in the space station, right? And they want to automate more tasks in the space station. And so they built this thing that, again, has to navigate its way around microgravity and do the tasks that we tell it to do. So when y'all are doing all of these different projects and trying to figure out how to take information and model it and come up with a good solution, right? Think about how different or similar these problems might be if your challenges and data include an extra dimension of Z because you're going up and down in space, or you have no gravity, or you have absolutely no idea what it's going to look like in the future, or you have zero contact with humans, right? Just a whole nother flurry of problems that we deal with when we go to space, and a whole nother potential set of solutions that we can use AI to make sure that our travel to Mars and interstellar travel as safe as possible. So that is my presentation for you. Hopefully that was a little informative about how we've been using AI in space and how we hope to use AI in the future. If y'all have any questions,